In this problem, we need to prove that a squared minus b squared whole squared, that's equals to ab whenever we have these two equations. So let's begin. First, we'll note down whatever is being provided to us. So here we are given, we have 4a, so that's equals to cotangent of theta whole multiplied to 1 plus sine theta. Let's label this as equation number 1. Then we have 4b, so that's given by cotangent of theta multiplied to 1 minus sine theta. And we're going to label this as equation number 2. Now, before proving that a squared minus b squared whole squared equals to ab, let's try to find out a times b, the product. So we're going to multiply equation 1 with equation number 2, which is going to give us, so we have 4 times a multiplied to 4 times b, so that's 16ab. Then we have cotangent of theta multiplied to itself, so that will be cotangent squared theta. And we have 1 plus sine theta multiplied to 1 minus sine theta, which will be equals to, so we have cotangent squared theta. Now when we multiply 1 plus sine theta with 1 minus sine theta, you can do this very quickly using the identity that a minus b times a plus b, that's equivalent to a squared minus b squared. So we're going to get 1 squared minus sine squared theta. So 1 minus sine squared theta, which is actually the value cosine squared theta, because we know that since, let's write it down, since sine squared theta plus cosine squared theta, that has a value equals to 1. So this is a standard trig identity. So we will going to get 1 plus sine theta times 1 minus sine theta will give us cosine squared theta. Right. So this is the value of 16ab. Now we're going to divide both sides by 16. So we have ab equals to 1 over 16 times cotangent squared theta multiplied to cosine squared theta. So let's label this as number 3. So here this ab represents the value on the right hand side of our proof. Now we'll start with the left hand side. So first let's obtain the value of a squared. For that we're going to take equation number 1 and then square it. So this is going to give us 16a squared, which is the square of 4a, and on the right hand side we have cotangent squared theta whole multiplied to 1 plus sine theta whole squared. So when we expand this, when we expand 1 plus sine theta whole squared using the identity a plus b whole squared, we're going to get 1 squared plus 2 times 1 times sine theta, so that's 2 sine theta plus sine squared theta. So this is the value of 16a squared. So let's label this as number 4. Then we are going to use the second equation, 4b equals to cotangent of theta times 1 minus sine theta. So we're going to square this as well. So we're going to square equation number 2 as well. That's going to give us 16b squared, which will be equals to cotangent squared theta multiplied to 1 minus sine theta whole squared, which will be equals to cotangent squared theta times, we will expand 1 minus sine theta whole squared using a minus b whole squared. So we have 1 squared minus 2 times a b plus sine squared theta. So let's call this equation number 5. Now what we're going to do is we'll take equation number 4 and from it we are going to subtract equation number 5. So this is going to give us 16a squared minus 16b squared, which will be equals to, so we have to subtract this expression on the right hand side of 4 with the expression on the right hand side of 5. So we have a common cotangent squared theta, and this is going to give us 4 times sine theta. Fine. So let's take 16 as the common factor. So we have 16 times a squared minus b squared will be equals to 4 times cotangent squared theta times sine theta. We can divide each side with 4. So we have 4 times a squared minus b squared equals to cotangent squared theta times sine squared theta. Now what we'll do, we're going to square both sides. Squaring both sides is going to give us 16 times a squared minus b squared whole squared, and on the right hand side we have cotangent of theta raised to the power of 4 times sine, this is not sine squared, this is sine theta. We're going to get sine squared theta. Now We'll divide both sides of the equation with 16. So we have a squared minus b squared whole squared, which will be equals to 1 over 16 multiplied to, so we have cotangent of theta whole raised to the power of 4. We can also rewrite it as cotangent squared theta multiplied to cotangent squared theta times sine squared theta, which will be equals to, now we have 1 over 16 times cotangent squared theta. Now cotangent squared theta, we know that the cotangent function, that is the ratio of the cosine function, cosine theta, to that of the sine function, which is sine theta. So that means cotangent squared theta will then become cosine squared theta divided by sine squared theta multiplied to sine squared theta. So we can cancel out sine squared theta from the numerator and the denominator, and this finally leaves us with 1 over 16 times cotangent squared theta times cosine squared theta, and we have already obtained this value. So we have obtained that this value 1 over 16 times cotangent squared theta times cosine squared theta, that's equals to AB as given in equation number 3. I've already obtained this value, so this will be equals to AB. So on the left hand side we have a squared minus b squared whole squared, and we found that this value is equals to AB, and this is exactly what we have been asked to show, hence proved.